Testing, testing, 1, 2, 3, testing, 1, 2. Hey, well. What a year, right? Wow. I really didn't expect that from the SMO. Okay, so in case you don't know what I'm trying to say, is that I think this year's SMO is going to be the most extreme of all. Wait, oops. I forgot the other side also play the audio. Wait, let me turn that off. Just give me a while. I need to turn the other volume. Okay. Okay. Yes. So, this is one of the most extreme years of this SMO because of the fact that I think, okay, so this is my own opinion. I think a lot of you will agree with me, in fact. But I think that the SMO junior section is, in fact, the easiest it has been in the past maybe 20 years, possibly. This is the easiest SMO junior section that is. Now, in comparison, there is the SMO senior section, which I'm currently trying to do, and I've been trying to do for the past so many hours. And I think it's the hardest one by far for the past maybe like 20 years as well. In fact, probably it's the hardest one ever in history for SMO senior. So somehow SMO junior became one of the easiest SMOs junior sections, but then the SMO senior section became one of the hardest ever SMO senior sections. So it's a very interesting relationship between the 2 years. Okay, anyway, let me finish this. And I want to finish this quickly so that I have enough time to go and prepare for my SMO senior round one review later on at 7:30 p.m. Okay, let's go through the questions. So question number 1, let m be a constant. If x plus 3 is a factor of x squared minus 2x plus n, which of the following is also a factor of x squared minus 2x plus n? So here, if you know that x plus 3 is a factor, right, then you can think of it as x plus 3 times x plus a is equals to x squared minus 2x plus n, right? And here, if you compare the two terms, you can immediately see, my x times x is my x squared, right? Okay, then where does the minus 2x come from? It comes from 3x and then ax, right? So from there, you can see that, okay, 3x and ax is negative 2x, so a must be negative 5. Finish. The other factor must be x minus 5. Okay, so that's question number 1. Quite straightforward. By the way, during the stream at any point, you can ask questions. Please feel free to ask questions in the messages. But because of the stream having a 20-second or more delay, I might take some time to get back to your questions. Okay. Question number 2 now. In the diagram below, 5 circles are arranged so that each inner circle is tangent to its adjacent inner circles and to the larger circles. And then I have a shaded quadrilateral here. The centers are the 4 circles here. And I want to find the diameter of the largest circle, x. What is the area of the shaded quadrilateral in terms of x? So the trick for such questions is first we need to draw all the main diameters of the circle, right, like this. So if the diameter of the largest one is x, immediately we know something. We know that this is going to be x over 4, and so on. Okay, it's a little bit small. Maybe I'll zoom in. Right? All this must be x over 4. Okay. And then what about the rest? Well, as for the rest, not so immediately obvious. But what you can do is that you can use, let's say, r for this smaller circle. So this is r, this is r, this is r, this is r, this is r. And then now what you can see is that, well, the radius here is also x over 4. This is also x over 4, right? So what we can do is that we can set up the equation involving this Pythagoras theorem with the right angle over here. I know that this horizontal length is x over 4. Okay, maybe let me show you this x over 4. And I know that this one here is going to be x over 4 plus r. What about the vertical one? The vertical one is going to be the entire x over 2, right, minus away the r on top, right? Okay. So as a result, what we have is this. So let me zoom back out. We basically have a right angle triangle. Okay. This is x over 4. This is x over 4 plus r. This is x over 2 minus r. So then we can set up equation. We can set up equation to solve for the value of r. Okay. We know that x over 4 squared plus this x over 2 minus r squared is equals to this x over 4 plus r squared, like that. And then we can expand. So we can expand, you can get x squared over 16. This is x squared over 4 minus 2xr plus r squared. This is equals to x squared over 16 plus half xr plus r squared. Okay, and then we can cancel them out. So cancel this, cancel this, cancel this, cancel this. And then in the end, you can get x squared over 4 equals to 2.5 xr, right? Wait a minute, something feels wrong. Oh, sorry, the left hand side I expanded wrongly. This is just x times r, sorry. Okay, so now this is correct. X squared over 4 equals to 3 over 2 xr. So x over 4 equals to 3 over 2r. We can now multiply by 4. X is equals to 6r. Actually, I don't need x equals to 6r because I'm perfectly happy with x over 4 equals to 3 over 2r, right? So from there, we can actually divide by 2 over 3. And sorry, not divide by 2 over 3, times 2 over 3 to get to x over 6 is r, right? So r is x over 6. And once you find that r is x over 6, how do you figure out the shaded quadrilateral's area? You just do half times this times this. Right? So half times this will give you the area. This will give you half times x over 2, right? Because x over 2 is the horizontal length. Right? And then what else? Times this one. This one is the vertical length, which is equals to, I think this is x over 3, right? So that one is x over 3 times 2, 2x over 3. And then in the end, the final answer will be x squared over 6. Finish. It was a bit tedious, but actually you can see that the idea here is not too difficult. Next question. Next question, question number 3. X and y are non-zero real numbers such that absolute value of x minus y equals to 4. Absolute value of x times y minus x cubed is 0. Find the value of x minus y. So from now on, what I'm going to do is that I'm going to recall certain type of ideas in relation to certain questions that you have done before, so that hopefully you can see what kind of ideas that you could have used. So this is very similar to a certain question which I taught the Sec 1 class just a few weeks ago. If they remember, there was this absolute value of x plus x, I think plus 2000, no, not plus 2009. Some expression, maybe it was plus some number of y equals to some constant. And then there's an absolute value of y minus y here, plus some number of x is some constant again. So for that question, what they did was that we split cases of x and y, depending on whether it's positive or negative. Okay, so that was the thing we did back then. So here, same thing for this question number 3. We want to split cases depending on whether x and y are positive or negative. So how to begin? So let's say if x is going to be, let's say, bigger than 0, then we just get the first equation is x minus y. Right. Okay, so this is equals to 4. So in other words, x is equals to 4 plus y. And then now, what you can do here is that, oh, okay, I just realized the second one you can divide by x actually. Yeah, you don't have to use the whole equation because x is non-zero, right? So if x is bigger than 0, then you can divide by x for the second one, it becomes y minus x squared equals to 0. So you get that y equals to x squared, so x minus x squared equals to 4, right, from these two combined together. But this is actually not possible to have any real values of x. Right? You can solve the quadratic equation to see that, or you can use the discriminant b squared minus 4ac. So if this is not possible, then we can conclude that in fact x must be less than 0. So if x is less than 0, what does the two equation become? Negative x minus y is 4, and negative x times y minus x cubed is 0. So then the second equation, you can also divide by negative x, you get y plus x squared is 0. And if you look at the first equation here, you can get that negative x minus 4 is equals to y. So what do we get here? You can combine them and get negative x minus 4 plus x squared is 0. Here there will be a solution for x. Okay, so here if you go and solve for the value of x, you can get 1 plus minus square root of 17 over 2. Okay, so I'm going to skip the calculation. I believe you know how to solve quadratic using the formula. And then what does that mean for y? Okay, actually for x first, we can conclude one more thing. We need to reject the negative case because, sorry, we need to reject the positive case because this guy is positive. So we reject. So the case that we must take is x equals to 1 minus square root of 17 over 2. Okay? And if you use this to find x minus y, how to find? Let me see. So you can go and find the value of y over here. Right? Y is negative x minus 4. Y is square root of 17 minus 1 over 2. Right? Minus away 4. So combined together, y is x minus y. X minus y will just be equals to option, is it D or E? So x minus y is option E. Okay, because you can get 1 minus square root of 17 over 2 minus away this guy. This is 1 plus 9 over 2, and then there's a minus square root of 17. Yeah? So that's the answer. Again, is this difficult? Not really. It's just quite tedious because you need to split cases. X bigger than 0, what happens? X less than 0, what happens? Okay, continuing on. Question number 4. Let A be this, let B be this, let C be this. Which of the following is true? Now, using your instinct, you should already feel that C is the largest, A is the smallest, B is somewhere in the middle. So you should already feel that the answer is E. Okay. But why you do have such an instinct? Why can we say that based on instinct, option C should be the right answer? Because option C is actually square root of 100 plus square root of 100. And the shape of square root is actually what we call a concave shape. So what does it mean for a concave shape? If you have a value of x you use here and a value of x you use here, for a concave shape, if you draw the line that connects the 2 points, the midpoint of it is less than the curve. So for any concave function, it looks like this. What we can see is this: f of a plus f of b over 2, the average of those two values, which is actually the midpoint over here. The average of those two values must be smaller than the function at that particular average. Yeah. Okay. So if you take, for example, in this question, fx to be square root of x, then what you can see in this question is basically you have f of 102 plus f of 98, f of 101 plus f of 99, and then f of 100 plus f of 100. Right? If I use this fact about the concave functions, you can see that definitely this thing is the biggest, and then so on and so forth. Now, if you don't like this argument, also can. You don't have to follow this. Another way to compare A, B, and C is to square them. Okay, so A squared will be equals to this squared plus 2AB, right? So 102 plus 98 plus 2 times the square root of this. B squared is equals to 101 plus 99 plus 2 times the square root of this. And of course, C squared is equals to just 400, right? But if you want to, you can write it as 100 plus 100 plus 2 times the square root of this. Also can. So now you can see that, okay, if I compare them, this is square root of 9 something? Is it 9? Wait, I cannot calculate. 9996, I think. Yeah. And then this one here is square root of 9999. And then this one here is square root of 10,000. Right. So of course, C is the largest, followed by B, followed by A. Okay. Yeah, but really what I'm hoping you to do is I'm hoping you that immediately you can see that based on your instinct, option E should supposed to be the right answer. If your instinct can show you that option E is correct, if you don't need to do all these workings, just move on. Okay? Since it's an MCQ question. Question number 5. Find the product of two real roots of this equation. This is very similar to that AIME question from, I forgot which year it was, 1983. Yeah. We use a substitution idea for that question. Same thing here. The idea is that actually we expand out the left hand side to get x squared plus 12x plus 36. After that, we look at the left and right side, we can see, they look pretty similar, right? So what we can do here is that we can make a substitution. Let, for example, let, for example, y be equals to x squared plus 12x plus 36. Right. Then what you can see over here is that the value will become y equals to 2 square root of y plus 1 plus 7. So now this is a very easy equation to solve. What you just have to do is to move the 7 over and then square both sides. Okay. So now we can rearrange the terms. We have y squared minus 14 minus 4, so it's minus 18y, plus 49 minus 4, so it's plus 45. And turns out this is factorizable because 45 is 3 times 15. This is y minus 3, y minus 15. Okay. So question, is y equals to 3 or is y equals 15 or both of them works? From this statement here, you can see that this guy is at least 0 because it's a square of something. Square of something plus 7, so y actually has to be at least 7, right? So therefore, the one that we must choose is y equals to 15. Y equals to 3 actually does not work. Once you know y equals to 15, then put it back into the equation. We have x squared plus 12x plus 36 is equals to 15. What do we have? X squared plus 12x plus 21 is 0. Here, you don't need to do any factorization, right? Because of Vitas theorem, right? Vitas theorem tells you that the product of roots is this guy. Finish. Okay, question number 6. Car A left village X for village Y at the same time car B which left village Y for village X. Both cars travel at constant speed. Then 5 hours later, the two cars pass each other. Another 3 hours later, car A reached village Y while car B was still 90 km away from village X. Find the distance between the two villages. Okay, so the idea is that if you draw it out. Okay, by the way, this is a very famous primary school math Olympiad question. Right? Okay, if you try to draw it out, A will leave here, meet at a point, and then continue on. B will also here meet at a point and then continue on, right? So the point at which they meet, actually you know that this ratio of distance must be 5 to 3 because of the fact that the speed is 5 hours for this and 3 hours for this, or rather the time, right? Time. So the distance is 5 to 3 means what? The distance is 5 to 3 here means that actually A's speed, right, to B's speed is 5 to 3. So now what we'll try to do is that we'll try to figure out what happens for the rest. So if this is 5 unit, this is 3 unit, in the same time that it takes A to cover this 3 unit, how much does B cover? So when A reaches the very end, B will have reached somewhere here, right? And this distance here will be 3 over 5 times of 3 units because I know that B speed is 3 over 5 of A speed. So then this one over here is 9 units. Sorry, 9 over 5 units. And that means that the leftover part over here in front must be how much? 5 minus 9 over 5, right? Which is equals to, how much is that? 5 minus 9 over 5 is 16 over 5, I think. So, yeah. Okay. So 16 over 5 units is equals to 90 km. What do I actually want to find? I want to find the total, which is 8 units. So here I can do divide by 2, divide by, divide by 2 times 5. So same thing here, divide by 2 and then times 5, you can get 225. Finish. So the key idea for this question is the ratio of time taken is the ratio of speed. Question number 7. Given 4 integers a, b, c, d, form another 4 new numbers where each new number is obtained by adding each of them to the average of the other 3 integers. So in other words, if you add a to the average of b, c, d, you add b to the average of a, c, d, and so on and so forth. Okay, so if you add a to the average of b, c, d, you can get, let's say 28, right? B to the average of a, c, d, you can get 37, and then c to the average of a, b, d, and so on. You should realize that the trick is to add all of them together. If you add all of them together, you can get exactly 4 times of a plus b plus c plus d, right, from here. But you can also get, no, not 4 times, what am I doing? 1 time of a plus b plus c plus d from here. But you can also get 4 over 3 times from the one behind, right? This one gives you, wait, no, sorry. This one gives you exactly a plus b plus c plus d as well. Because here you have a a over 3, a over 3, and a over 3. Together, this is a. Right, same thing here, b over 3, b over 3, b over 3 is b, and so on and so forth. So the second part also gives you exactly a b, c, d. So this is 28 plus 37 plus 46 plus 57. And then if you calculate out, you can get 168. So when you divide by 2, a plus b plus c plus d is 84. Very nice. But that's not the average though. The average, they want what? 84 divided by 4, right? 21 should be the average of the 4 numbers. Okay, question number 8. The following is a 3 by 3 grid with 3 cells filled in with 3 positive integers 1, 2 to 1, and m. Find the value of m so that it's possible to fill in the remaining 6 empty cells so that all the sums in every row, column, and diagonal are the same. So this is a magic square basically, a 3 by 3 magic square. How do I do this question? Well, we label the squares that we don't know, right? We label the squares that we don't know. So maybe I label them A, B, C, D, E, F. Okay. The way we're going to find M is that we're going to compare the things across the rows that contain 2211 M as well as the diagonals. Okay, firstly, you get the sum of every row and column is A plus 221 plus E, right? If I look here, it is also E plus 1 plus F. So theoretically, we already know the difference from A and F just by looking at this. But that's not very important to me as of right now. What can I conclude as well? Is also equals to this guy, right? E plus C plus M. What else can I conclude? Is also equals to this guy, AC and F. Okay. Now, is there a way for me to find out? Okay, not yet actually. Not yet. Find out M. Okay, so my idea was that maybe I can use this guy. Again, I can use maybe these two guys to subtract away this guy. But then I just get something involving E. Do I need to use these two? I try to avoid using them if I can. But maybe I need to use them. Oh, okay, wait. Here's the idea. Okay, I know already how to do. Actually, turns out I don't need the last row. Now, a fact about magic square that you all should know. For magic square, the middle, or rather the center, is the average of everything. Right? For example, in the basic 3x3 magic square, where we have, okay, what's the 3x3 magic square array? Again, 3, 5, 7, 4, 9, 2, and 8, 1, 6, right? In the basic 3x3 magic square, the middle number 5 is the average of the other 9 numbers. Sorry, all 9 numbers basically. Right, the center is the average. So what we can do here is that actually we can use one very important condition. If the center is the average, for example, if you take a look at this one here, you can notice something. 4 plus 6 is 2 times of 5. 3 plus 7 is 2 times of 5. 8 plus 2 is 2 times of 5. And finally, 9 plus 1 is 2 times of 5, right? So in addition to these conditions, we also have A plus F is 2C, because C is the average along here. And if A plus F is 2C, now actually we are done. Because what we just need to do is that you can see that, okay, 2 times of the sum is A plus 221 plus E plus E plus 1 plus F, adding these two together. But 2 times of the sum is also 2E plus 2C plus 2M by doing this times 2. Now, compare them. 2E is 2E. Cancel that out. It's gone. Right? In fact, let me draw that out. So 2E is 2E. This part is the same. A plus F is 2C. So 221 plus 1 must be 2M. Finish. M must be 111. That is the answer. Okay. Now just for fun, let me mention a fun fact. Any 3x3 magic square is of the form ax plus b. It's a linear function basically, but it's of the form a times 492,357,816 and then plus b. So what does it mean by that fun fact? You don't have to know this, but any 3x3 magic square must be some multiple of the original. Some multiple of the original 3x3 magic square and then plus some kind of constant. Yeah, so that's the idea. So this is a pretty interesting fact about your magic square. And actually what that means is that these two things, the average will always be this, right? These two things, the average will always be this. And then what else do I have? These two things, the average will always be this one. And then these two things, the average will always be this one. So whenever you have this kind of combination, this one, you can always conclude that M is the average of the other two based on this fact over here. Okay, question number 9. Question number 9 is quite simple. We have x equals, we have x plus 1 absolute value, x minus 2 absolute value, x minus 4 absolute value. The trick is to think of it as distances. This is the distance of x from -1. This is the distance from x to 2. This is the distance from x to 4. So for example, if x is a point here, then this value represents the length of this. This value represents the length of this, and then this value represents the length of this. So if I want to minimize the sum of lengths, what I do? You should notice something. Firstly, it doesn't make sense for the point to be here or here, right? Because the lengths will be too big, right? And for any point that's between -1 to 4, you can realize that this part and this part will always add up to 3. Right? These two things will always add up to 3. So if these two things always add up to 3, then the trick is I just need to minimize this value. How to minimize? Let x equals to 2. If x equals to 2, this value is 0. So then you just have this the other 2. So this value here plus this value, which is 3. Finish. Oh, wait. I just realized. The distance from -1 to 4 is 5. It's not 3. I got confused. Sorry. Right. The distance from -1 to 4 is 5, not 3. Sorry about that. Okay, next. Question number 10. This one looks a bit scary, but it's relatively standard. What's the trick here? First, we should make a substitution, right? Let this be x. Then this is 1 over x. So what is x? X is this guy, right? Let's try to rationalize it. So rationalize it means what? Means that we can multiply by square root of 5 minus plus 1 over square root of 5 plus 1. The denominator becomes 4, right? Because it's 5 minus 1. It's a minus b times a plus b. And then now the numerator becomes this thing times this thing, which is equals to, what's that? A plus b times a plus b, right? So it's a squared plus b squared plus 2ab. So together the answer is 3 plus square root of 5 over 2. That's the value of x. Okay. Now, what is 1 over x then? Very interestingly, 1 over x will be 3 minus square root of 5 over 2. The reason is because, if you notice, these two things, their product is equals to 1. Right? The product of these two things is equals to 1 because of the fact that 3 plus square root of 5 times 3 minus square root of 5 is 9 minus 5. And then 2 times 2 is equals to 4. So therefore, this is the value of 1 over x. Now, of course, you could also just done 1 over x here and then try to rationalize it, right? You could also have gotten the same answer. Okay, so now to find x to the power 4 plus 1 over x to the power 4, we are not going to expand it out, obviously. We are going to do what? We're going to first find x plus 1 over x. So this plus this, well, obviously, that's 3. And now using this, actually, we are done with the question already. Because from here, I can do 2 steps. I can square it. When I square, I can get x squared plus 1 over x squared plus 2. This is equals to 9. So, x squared plus 1 over x squared is equals to 7. And then I can square it again. X power 4 plus 1 over x power 4 plus 2 is 49. So the answer for this question is 47. Finish. Okay, let's move on to question number 11. So question number 11, we have a 5, 12, 13 triangle, which means it's a right angle triangle. Points D and E lie on the two sides so that DE splits the area into two equal parts. I want to find the least possible length of the line DE. Now this question, again, you need to train your intuition. Where do you think D and E will be so that this line is minimized? Well, first you might think, oh, D and E are both the midpoints, right? But if they're both the midpoints, then this area is 1 over 4 of the original triangle's area. The answer is D and E will be points so that it is isosceles. Because what happens if it's not isosceles? You can also get the same area, for example. But this line should feel a lot longer than the case with the isosceles, right? Think of D and E as points that can move on both of the lines. If D moves here, E will move here, right? So like that, where do you think D and E will be the shortest? Probably when they are both roughly equal, right, in position. So you should feel that the isosceles triangle is the one with the best result. Now, we can try to justify that. Okay, we can try to justify that. The reason, right, why you want isosceles triangle for the best result is because of cosine rule. So personally, I think this is one of the trickier questions on the worksheet, maybe even the hardest one, because probably you all won't think of using cosine rule for this question. Okay, so how to use cosine rule here? Firstly, we focus on angle A. Cosine of angle A is going to be this adjacent over the hypotenuse, right? 12 over 13. And what we can do here now is that we can apply something. We can apply cosine rule to this triangle. Okay? We can apply cosine rule to this triangle. So DE squared equals to AD squared plus AE squared minus 2AD times AE times the cosine of angle A. Turns out, we know what this is. We know that this thing here must be half of 12 times 13. How come? How come we know the value of this? Well, because of the fact that this is a well-known fact about triangles. If you have a triangle within a triangle, then the area ratio of these two triangles is this over this times this over this. So the area ratio in this question, they tell you, oh, DE splits it into half. So this triangle is half of the whole thing, which means that this over this times this over this is half. Right? So which means that AD over AB times AE over AC is half. So let's write it down. And if I know that this is equals to half, we also know that this is 12 and 13, then we know what? We know that AD times AE is just half times 12 times 13, right? Is 78, I think. Yeah. So it is always going to be a fixed value over here. Right? So this thing is fixed. So if this thing is fixed, how do you minimize this guy? How do you minimize x squared plus y squared if you know that x times y is fixed? Right? So if you want to minimize x squared plus y squared given x times y is fixed, the answer is just x equals to y. Okay? So one way to confirm this is to apply the AMGM inequality. But I think you should also feel intuitive, right, that this is true. X squared plus y squared is minimized if x equals y. Okay, so then AD and AE are the same. But if AD equals to AE, then we know what these numbers are supposed to be, right? Because we calculated here AD times AE is 78. So this is 78, this is 78, and this is also going to be 78. So therefore, this is equals to 156 minus 156 cosine of A. And so the result is 156 times 1 minus 12 over 13, right? Because I can put this value back in here. This is 12. So then DE is square root 12. But anyway, what that means is that the answer for this question is 12. So quite a few steps for this. This fact is the fact that you must know. And using this fact, you know that this time this is fixed. And then this is the one that is quite surprising. the fact that the cosine rule is also introduced in this question to help you get a expression for DE. Okay. Okay. Now let's move on. This question number 12 here, we've seen something like this before, right? In my Sec 1 advanced class, we talk about multiplying certain things. We talk about multiplying a plus 1, a plus 2, a plus 3. Right? Back then, you should know that the key idea for such a thing is to do this pairing and do this pairing. So same thing here. I will do a plus 3 times a plus 11 and a plus 4 times a plus 10. One of them is a squared plus 14a plus 33. One of them is a squared plus 14a plus 40. How to find a squared plus 14a? Now that is the part that's quite interesting. A squared plus 14a is a times of a plus 14, right? So it is negative 7 plus square root of 5 and then 7 plus square root of 5. So therefore this is equals to what? This is equals to a negative 49 plus 5, negative 44. Okay, so then we now know the two values here. We can go back and substitute. This guy is negative 4, this guy is negative 11. Final answer, 44. Finish. So this is the part that I start to mention questions that a lot of you have seen before. Like for example, this one definitely you have seen before. In our Sec 1 class, we explained this idea many times. But so have we explained this question? In fact, I can name exactly which question this is from. This is our Sec 1 Sem 2 Lesson 7 question number 1. Okay. If you go back, if any of you happen to have the worksheet with you, you can go back and refer to that. Sec 1 Sem 2 Lesson 7 question number 1. The idea is that this angle x here is the average of these two. Okay, but before that, let's read the question. Huh? So BF is the angle bisector of angle ABC, so these two angles are the same. DF is the angle bisector of this angle ADC, so these two angles are the same. So then I want to find x. So the reason why x is just the average of the other two angles is by angle chasing. So for these two angles, let's call them both angle A. For these two angles, let's call them both angle B. And then I'll call this angle C. And I'll call this angle D. The 36 degrees from angle A, there's a formula we can write for it. 36 degrees is 180 minus away the other angles. So minus away the angle at D, minus away this 2A plus C here. Then the 58 degrees, we can also have a certain value, right? Using this triangle here, this is 2B plus C, 2B plus D, this is C. So we can write down 58 degrees is 180 minus 2B minus D minus C. But now, if you compare with x, you can see that x is 180 degrees minus away this angle, minus away this angle, right? Minus ABCD, in fact. And hopefully, you are able to see that the average of these two values is exactly this guy here, right? Because both of them have 180 degrees. If you combine them, there's a 2A, there's a 2B, there's a 2C, and then there's a 2D. So if you add up these two values, you divide by 2. That's this guy. So therefore, the final answer, x is just the average of 36 degrees and 58 degrees. Finish. 47? Yeah, 47. Okay, question number 14. Question number 14 is a question where your instinct needs to be strong because because of seeing types of question before. Now, unfortunately for my Sec 1 class, I don't think I have a chance to go through with you all this thing yet. But for my Sec 2 class, I've definitely gone through this idea with you before. When you see such a thing, two expressions involving square roots, and then within the square roots there's squares, and you want to find the smallest possible value. Immediately, this should jump out to you that this is Pythagoras theorem. I've mentioned this idea to you before for my Sec 2 class, that we can use Pythagoras theorem for these kind of questions. How? Well, after you figure out its Pythagoras theorem, then the steps should be more or less doable, because you should know that, okay, if I have Pythagoras theorem, I need to have square root of a squared plus b squared, right? So I need to get two square numbers from here. Same thing, I need to get two square numbers from here. So let's complete the squares. In fact, this is x minus 1 squared plus y minus 2 squared. Right? You should see that this makes sense, because the 5 is split 1 into here and 4 into here. Then the one behind, you should see that this is going to be x plus 2 squared plus y plus 2 squared. And now here's the interesting part. How do I combine these together to form Pythagoras theorem? We're going to make the first one. Okay, we're going to start with the second triangle first, because it's easier. The second triangle is just going to be x plus 2 by y plus 2. Right? So then the hypotenuse is going to be this guy. And now for the other triangle, here's what we're going to do. We're going to replace this guy by something else. We're going to replace this guy by 1 minus x squared plus 2 minus y squared. What this enables us to do is that it enables us to create a right angle triangle, but with the sides being 1 minus x and 2 minus y instead. Okay, so let me create one, for example. So let's say this is 1 minus x, let's say this is 2 minus y. Now I want the smallest value of this plus this, but by triangle inequality, we can see that the shortest distance is this line connecting them. Okay. Let me use a different color. The line in red color is the shortest possible value of this plus this, because triangle inequality, right? So if let's say this point, this point right here was over here, then you can see that it makes sense, right? They're exactly equal. So what's the dimensions of this? This is x plus 2, this is 1 minus x. So this horizontal length is equals to 3. This is 2 minus y, this is y plus 2. So this vertical length here is equals to 4. Therefore, this is exactly a 3, 4, 5 triangle. Okay, question number 15. Now this one we didn't really go through with our Sec 1, Sec 2 class, because the idea is a bit uncommon. But a very interesting fact is that, in fact, I went through this thing with my P4 students this morning. So I was in charge of teaching the P4 class this morning, and then there was some question that is kind of like this. So I'll use the exact idea I went through for that class back then. Now it looks like you need to check divisibility for 2, 3, 5, 7, but that's going to take you a long time to check. I'd rather not check the divisibility. The idea for this question instead is that, why not let's just try to find what 3-digit whole numbers ABC will make sure that this is divisible by their lowest common multiple, which is 210. So to figure out when this is divisible by 210, in fact, I'm going to start by using this number, 123,999. I'm going to find the remainder when this number is divided by 210, and I'm going to use this to find what ABC can be. Okay, so divide by 210. I think this is a 5, yes. It looks like a 5. 1899, right? Then this is a 9. Yes. Then 99 here, of course, is not divisible, right? So the remainder is going to be 99. So what can we figure out works if this remainder is 99? Immediately, you should be able to see that a number that works is 1239000, right? Because I just need to subtract the remainder of 99 and then this number works. So if this number works, is this the only one? No, right? I can also subtract off 210 to get 690, subtract off 210 to get 480, subtract off 210 to get 270, and subtract off 210 to get 060. Okay, so we need to sum them up. But here's where you need to be careful. I think the last one has to be rejected because of the fact that 060 is not 3-digit. Right? 060 is a 2-digit number. So the final answer for this question actually will be 900 plus 690 plus 480 plus 270. What's this? Is it 2340? I think so. Yeah, so that's the answer. Okay, continue on. Question number 16. This is factorizable straight away. This is x plus 2y, x plus y. In 2026, there's also only one factorization, 2 times 1013. Okay, sorry, not one factorization. Cost could also be 1 times 2026, right? But what I mean is this. What I mean is that the prime factorization is basically this. Because 1013 is a prime. Okay? Now, what does that mean? This will give you a solution, right? Because how to find y? Y is just you take whatever this is minus whatever this is. So it will always be an integer, right? Let's say it's 2 and 1013. Then it's going to be y equals negative 1011. It will always be integer. And then x will be some other value, basically. So you can see that this will give you integer, but so will 1013 times 2, and so will 2026 times 1. This will give you different values of x and y. But so does the negatives. If you have negative 2 times negative 1013, it should also give you a solution. If you have negative 1, negative 2026, and then the same thing flip around, it should also give you different solutions. So the answer turns out to be there should be 8 pairs. You don't need to figure out what is the x and y values because they never ask you, but you know that there will be 8 pairs, right? Each one of these will give you a different solution for x and y. Okay. Question number 17. Question number 17 actually is the question I got stuck at for the longest time on this worksheet. But when I solved it, I don't think it was that hard. It's just that I wasn't able to see something. But even though this took me the longest time on this worksheet, I think still took me less than 10 minutes. I think, forget already. Because overall, the paper difficulty is not hard, right? So the question says 8, 4, 4, 2. And using this, find the total area of unshaded regions. Now, the first thought in my mind that crept over is that, okay, maybe somehow this shaded area is exactly half of both rectangles. Maybe, right? Because then like that, the calculation will be very nice. But that means I still need to figure out what this side is, right? If I don't figure out the side of the rectangle, I can never do it. Then the second thing maybe I was thinking is that, okay, maybe I don't need to figure out that side. Maybe I just need to cut and paste this into, for example, like an 8 by 8 square. But also, I was thinking to myself, this looks quite a bit bigger than 8 by 8 square. Plus, if I extend this further on to the left, then obviously the area is going to be very big, right? It's going to be bigger than an 8 by 8 square. So with those two facts in mind, I pretty much confirmed that I need to find the last side of the triangle. Of the rectangle. And here's the trick. The last side is to use this shape over here. Because we know that the diagonal here is part of 2 right-angled triangles. The diagonal here is part of 2 right-angled triangles, here and here. One of them is 8 by some unknown. One of them is 4 by some unknown. But I know the relationship between these two. If I set this as x, then the one on top must be x minus 2 because of the fact that this whole length is x. Suddenly, I have Pythagoras theorem. I know that x minus 2 squared plus 8 squared must be x squared plus 4 squared. Okay, so we can figure out that x is equals to 13. After you find x equals 13, how to finish off the question? You can go and just, yeah, how to finish? Okay, you need to go and find these two areas, right? And then you go and subtract off from the one on top and then from the one below. Right, yeah. So x equals 13 tells you this area is 26. 8 times 11 divided by 2 is 44. Right. The whole thing is how much? The whole thing is 8 times 13 is 104. So 104 minus 26 minus 44 is the one left over for the one on top. Is this one? But actually 104 minus 26 minus 44 is also the part left over here. So the answer is twice of this, which is 68, I think. Yeah. Okay. Question number 18. This is in fact the first question I started trying when I was doing the worksheet because I wanted to jump around to different questions. Now, when I saw this question immediately, without even looking at what they're asking, so I wasn't looking at here, I saw some similarities between this question and the question we went through in lesson number 22 of Sec 1 semester 1, comparing coefficients. So back then we had some question that looks like, I forgot the question already. Something that looks like this, I think, maybe. And then back then the solution we did is that we just multiply by a plus b on both sides. So same thing for this question. We are just gonna multiply by a minus b. Okay? A minus b over a plus a minus b over b equals to 1. So 1 minus b over a plus a over b minus 1 equals to 1. So a over b minus b over a equals to 1. And suddenly, we have a quadratic equation. Now you might be asking, where is the quadratic equation? But what you can do here is that we can let, for example, a over b equals to x. Actually, no, I want to let the other guy be equals to x. Let b over a equals to x. Okay? And then now what I have is 1 over x minus x is equals to 1. So this is a quadratic because now I can multiply by x to get 1 minus x squared equals to x. So 1 equals to x squared plus x. Right, or 0 equals to this. So we can solve for this quadratic to find x. What's x going to be? Negative b plus minus square root of b squared minus 4ac over 2a. Okay, now it appears there are two different answers. From the fact that this is the SMO, you should already realize that, oh, the answer should be the positive value, right? Okay, but why? Well, because they are positive real numbers. Right? If x is negative, then this is negative, which doesn't make sense. So x has to be positive. So x has to be this guy. And you can easily see that this guy is going to be between 0 and 1 because square root of 5 is roughly 2.2, right? So if you take 2.2 minus 1 is 1.2, divided by 2 is 0.6-ish. Right. And in fact, x is exactly the golden ratio minus 1. So it's going to be like 0.618, blah, 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 blah. So yeah, b over a, when you round up, it will be equals to 1. Finish. Question number 19, we have a very straightforward application of our AMGM inequality. So let's recall what it is. AMGM inequality just says that, x plus, maybe let's use a and b. A plus b over 2 is at least the square root of ab. Right? So 4x plus 9x is at least 2 times the square root of 4x times 9 over x, which is 2 times square root 36, 12. Okay, next question. Question number 20. Now, question number 20, this is a question which is, how do I say this? I don't think any of you should have seen this type of question before, but I have. Because this kind of question is a very weird and very unusual question. Okay, what does this question say? You have a function fx that is the minimum of three values. And of course, it depends on x. For example, f2 is the minimum of 9, 4, and 1, which is 1. Find the maximum value of fx. So a maximum value of the minimum of three function. It turns out there's a value that this cannot cross. So this value of fx, there's a largest value that you always stay underneath. So we want to find that. And because I've seen this type of question before, I know how to do them. The way to do this kind of question is by graphing. Let's graph them. In fact, the last time I saw this question, I remember plotting exactly y equals to 4x plus 1 and y equals x plus 2. So this thing versus the last time the question, they only changed this very last number. I'm pretty sure. Yeah, I'm pretty sure they only changed this last number. So y equals to x plus 2, that one's pretty easy to draw. That's 45 degrees right here. Like that. So this is obviously 2. Right. What about y equals to 4x plus 1? Y equals 4x plus 1 will pass through 1 here. But then you should realize that it will have a gradient of 4, right? So it's really, really slopey. It will take over the other guy pretty quickly. So maybe it's even more slopey than this. So maybe I'll do like maybe like this. Right. So you'll take over the other guy really, really quickly. Like that. Okay. And then the last guy, y equals to 5 minus 2x. You can see that 5 minus 2x, when x is 0, is at 5. And it will slow down with gradient of 2. So something that looks like this. Okay. Y equals to 5 minus 2x. So what is this function fx? Fx is very interesting. This is what fx looks like. Okay, I'm going to highlight out for you. Fx is here. And then at this point, you realize that this line is no longer the smallest one. At this point, you realize that actually this line is the smallest one. So fx takes a turn. And at this point, this one takes over to being the smallest one. So that's this. So this is the graph of y equals to fx. So therefore, to find the maximum value of y equals to fx, we just need to figure out what is this value, right? What is this value? So we want to find the intersection of 5 minus 2x and x plus 2. We can see that this will happen when 3x is equals to 3, right? So x is equals to 1. And what's the value here? F of 1 is equals to 3. That's the answer. Finish. Okay, question number 21. Question number 21, we're dealing with factorials. In fact, for question 21, we have a telescoping series. But this telescoping series is a little bit hard to spot because you need to try to imagine, can I express this factorial as a difference between two values? So the trick is that n times n factorial, we can write it as a difference of factorials. Write this as n plus 1 minus 1. And then when I multiply by n factorial, I can just get n plus 1 times of n factorial minus n factorial, right? And then the first one becomes n plus 1 factorial. The second one becomes n factorial. So now I've expressed it as a difference. So then the expression will be 2 factorial minus 1 factorial plus, this one here will be 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial all the way until the last one. 1013 factorial minus 1012 factorial. So this sum is exactly 1013 factorial minus 1. Okay. Now, 1013 factorial divided by 2026, remainder is 0. So this is congruent to negative 1 mod 2026. which is congruent to 2025. So therefore, the remainder will be 2025. Okay, next one. Question number 22. This one I feel is equally as hard as that question that I said was the hardest question on the worksheet, which was, where was it? Question 11. But I think that some of you, actually, okay, maybe it's a bit hard. The reason why I was able to do this question is because I recognized that there was a question very similar to this in one of your worksheets for the Sec 1 advanced class. So the Sec 1 semester 2, one of the geometry worksheets. But the question that I'm talking about is not a round one question. The question I'm talking about is a proving question. Here's the setting of the question. You're given an equilateral triangle. You draw a line over here such that this length, maybe let's use green color, such that this length is equals to this length here. Okay. What was the setting of the question again? I forgot. Show that this is equals to this. That was the setting of the question. Now, if you have no idea what I'm talking about here, then there's no reason for me to explain more about this question. But this question was a big inspiration for me for this idea. Because back then, the solution for this question is to draw the same thing on the other side and show congruent triangles. When you show congruent triangles that this triangle is congruent to this, you're done. You have shown that these two lengths are equal. Now let's take a look at this question. BC is 4. M is the midpoint of AB. CA is equals to 2 of CM. Immediately I'm thinking, okay, midpoint and a 1 to 2 ratio. Can I do something with this? My first instinct was to do this. Draw a congruent triangle on the other side. But it doesn't quite work. Because why? If you draw a congruent triangle, yes, you know this is 60 degrees. Yes, you know this is 1 unit. Yes, you know that this is isosceles. But there's nothing much you can do about this. There's nothing much you can do. So that brings me to the idea over here then. So my second idea was, okay, maybe if I draw here doesn't work with M being a midpoint, maybe I can draw another thing. I can draw a line that is parallel to MC. If I draw this line parallel to MC, okay, what happens? This is the midpoint. If this is parallel to this, then this is the midpoint as well. So C is the midpoint of, let's say, BD. So this will be 4. But then if this is the midpoint, then this is 1 unit, means that this thing here will be 2 units. And that means that this thing here is isosceles. And then suddenly, this question comes in. So when I was staring at this diagram, my idea was that, okay, this is the reverse of that question. Now we know that these two things are equal to each other. If I know that these two things are equal to each other, and if I know that there's a 60-degree angle, what do I do here? I construct an equilateral triangle. Okay? I draw an equilateral triangle right here. And turns out when I draw the equilateral triangle right here, these two triangles must then be congruent. Because 60 degree, and then 2u and 2u, and then what's the last one? Last one is this, right? This side is equals to this side. Okay, actually technically that is not true, right? It is not true because that is SSA. It's SSA. But you can fix that very easily because isosceles triangle, so these two angles are equal to each other. So then these two angles are equal to each other. So you can turn it into an AAS, right? So instead of doing an SSA, you can do it AAS. But either way, they'll be congruent. So then we know that the bottom length is 4. And once you know the bottom length is 4, you know that the side of the equilateral triangle is 12. So then this thing here must be 6 and 6. Okay, now to finish off the question is quite straightforward. There's 2 ways to finish off. If you know cosine rule, straight away you can apply it here. Right, to finish off the question. But if you don't know cosine rule, then maybe what you can do is to draw the height of the triangle downwards. Right. Basically, this is a 2. But in the 30, 60, 90 triangle, we know that if this is 6, this should supposed to be 6 times square root 3, right? So then we can see that, oh, AC squared will be 2 squared plus 6 square root 3 squared. This is 4 plus 36 times 3. Right? So 4 plus 108, 112. So therefore, AC squared is 112. You can see K in this case must be 112. Finish. Now, I don't think my method is the best because my method uses a very obscure fact I happen to know because of the fact that I did this particular question back in Sec 1 Semester 2, one of the geometry worksheets. If any of you have a better solution for this question, which I'm sure there should be, please feel free to write in the comments because I don't think my method is the best, although it works. But you have to admit my method is pretty nice, right? Because of the fact I created congruent triangles here and there. Okay, continue on. We have a 7-digit whole number formed from digits 1 to 9. Very important that it's 1 to 9. And the digits may repeat. Suppose that for each k 1, 2, 3, 4, 5, the 3-digit number formed by 3 consecutive digits is divisible by 3. So that means this is divisible by 3. This is divisible by 3. This is divisible by 3, and so on and so forth. Okay. Now this question, although it looks scary, it wants you to find the number of such n. In fact, this is one of the easiest questions in the worksheet. How come? Because from A3 onwards, you always have 3 choices. If your number so far, okay, for example, you want A1, A2, A3 to be a multiple of 3. If your number so far in front, the sum of digits is 0 mod 3, what can you choose as A3? Either 3, 6, or 9. If your sum of digits in front so far is 1 mod 3, what can you choose as A3? 2, 5, or 8. If your sum of digits in front is 2 mod 3, you can choose A3 as 1, 4, or 7. So for A3 onwards, you have always 3 choices, no matter what the previous digits are. So no matter what A2, A3 is, A4, there will be exactly 3 choices. And this is granted because of the fact that the digits are from 1 to 9. So therefore, the answer for this question is 9 choices for A1, 9 choices for A2, and then every subsequent digit, there will be 3 choices. Finish. That's the answer. Okay, so this is 3 to the power 9. Here, I'll skip the calculation because it's just you calculate a power of a number. Not very fun. This will be the final answer. Question number 24, we have a number theory question. Product Mn is a perfect square and n minus n is a prime number. Immediately I stare at this and know that, okay, this is a number theory kind of idea, right? When can a product of 2 numbers be a perfect square? Case 1, when m is a square number itself and n is a square number itself, right? The product can be a perfect square. But this case 1 you can see is pretty easy to deal with because case 1 tells you, oh, a squared minus b squared is prime. Right? And when a squared minus b squared is prime, this means that it's supposed to be what? It's supposed to be 1 times something, right? Okay, it's supposed to be 1 times something. 1 times the value of what's this? Okay, I don't know what this is, but we can figure it out slowly. In fact, actually, we know what this is because a minus b is 1, so this guy here must be 2b plus 1. Okay? So a is b plus 1 from here. So this guy here must be 2b plus 1. So we just need to figure out when 2b plus 1 is prime. And if you take a look at the conditions given to you, you can see, okay, m is between 33 squared and then 45 squared. Right? So a is between 33 and 45. So B is between 32 and 44. So 2B plus 1 is from 65 to 89, right? How many prime numbers are there from 65 to 81? Okay, we can start with our favorite number. And then now we can move on to 71, 73, what else? I think 79 is a prime, right? 83 is a prime, I think. 87 is divisible by 3 and 89 is a prime as well. So there should be 6 of them in case 1. Okay. Now, let's deal with case 2. Maybe I may create a new page here. Actually, don't need. I think I can fit everything in. So case 2. Now, what happens when they are not square numbers? Why I want to do case 1 as they are square numbers? Because it's possible that they don't share any common factor. Right? If they don't share common factor, each of them must be a square number. So actually, my case 2 is when they do share a common factor. So let's say the common factor is D. So we can say that maybe you let M be equals to D times some number, let's say call it A. Maybe let's not use A again. Maybe D times X and N be D times Y. Then XY is a square. So assuming that X and Y, they don't share any common factor, what happens when XY is a square? Means both of them must be squares. So actually you can do over here D times X squared and D times Y squared. But either way, from the fact that you can see both of them that should be square numbers, right? To make sure that M times N is a square number, you can really see, okay, M minus N. Wait, I just realized. Case 1 is actually a subset of case 2. Because case 1 is when D equals 1. Okay, so I shouldn't have actually bothered splitting cases here. Okay, but never mind. You notice that M minus N is D times of X squared minus Y squared. So if D is bigger than 1, I think you can very easily see this is not prime. Right? Because if D is bigger than 1, you can also notice something. X squared minus Y squared is also bigger than 1. Right? Because these are two square numbers, and the only square numbers that can have difference of 1 is 1 squared minus 0 squared. Can Y be 0? Cannot. If Y is 0, N is 0, right? Which contradiction. So X and Y are both bigger than 1, which means that this difference of squares must be bigger than 1. So not possible. Okay? So there are no cases for case 2. Finish. The answer for this question is exactly 6. Last question, question number 25. Again, looks a little bit scary, but people who have attended my Sec 2 lesson 10 on algebraic manipulation and sums should have seen this question. This is a geometric series question. So square ABCD side length 32. Now they tell you that it's split 1 to 4, and it does this throughout. So this is 1. The 4 is the entire thing. So actually it is 1 and 3. We just need to figure out what happens in the base case, where you start with this, and then you do this, 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 this. What happens in this case here? In this case, you can use Pythagoras theorem. 1, 3, 1, 3, 1, 3, 1, 3, and this is square root of 10. So the area of the square inside to the whole thing, the small square to the big square, is simply just going to be 10 to 16. Right? Because square root of 10 times square root of 10 is 10. 4 times 4 is going to be 16. So this is 5 over 8. So every single time I repeat this process, I get a square which is 5 over 8, the original size of the big square, right? So we start from here, we do this one, this becomes 5 over 8 as big. And then we do the next one, becomes 5 over 8 as big. We do the next one, becomes 5 over 8 as big, so on and so forth. So how to do? Well, it's just you add 5 over 8 of the whole thing. And then what about this one? At this point, you have done 2 copies of 5 over 8 already, right? Wait, no. Sorry, what am I doing? sorry, this shaded area is not 5 over 8. This shaded area is actually 3 over 8 of the whole thing, right? Then you do a 5 over 8 to get here, and then you do another 5 over 8 to get here. So then this one here is 5 over 8 squared times 3 over 8. So therefore, the shaded area is this much of the total area of the big square. Okay, so now we just need to go calculate. Okay, what did they tell us is the big square side length? 32. So we take this times 32 squared. Whatever this is our answer. How do I calculate this? Let me see. 3 over 8 times 32 squared is 20, 12, 32, 664, 384. And then the other one is 150. So together it's supposed to be 534. Finish. Okay, so that's it for the SMO Junior. As you can see, there's no particularly difficult question except those two geometry questions. Surprisingly, the hardest topics here are geometry for this year. But even then, there's not too many, I would say, difficult questions. Okay, that's all. If you have any questions, you can stay back and ask. I'll stay here for a few minutes before I go and continue preparing for my SMO Senior, which I'm still doing and it's still giving me so many problems. That paper is super difficult. Okay, I see no questions. I'll stop my stream here. Bye bye.